developed by Open Hydro Limited, an Irish company, AEMEC, in Orkney. Very different type of device. Interestingly, for the electrical engineers amongst you, the power engineers, this uses a direct drive power takeoff system. Quite different from the gearbox and generator of the MCT system. This is Oyster, also originally designed by Trevor Whitaker. He's been a busy man over the years. Conceptually very simple. It's just a flap that moves back and forward. Pumps seawater through a flow line, through a Pelton reel. And of course, it's no longer just a data's impression. There's the reality, generating electricity into the Orkney grid. This is an amalgam of scenarios that different organisations have put together, different governmental organisations, different predictions of how much technology we'll have in the sea. Don't confuse this with resource assessment. This is a politician's dream rather than reality. If that is going to be achieved, and they're looking at 2 gigawatts installed capacity by 2020, governments have to do something to make it happen. One or other of the so-called policy drivers. Now, the original policy driver was the non-fossil fuel obligation, NIFO, which quite cynically was actually there to support the nuclear industry in the early days. It was nothing to do with the renewable sector. It was replaced back 6 years ago now by the renewable obligation. And the renewable obligation allows the existence of a parallel currency of ROCs, renewable obligation certificates. This means that if you supply a megawatt hour into the grid, you don't just get the payment for that megawatt hour, you also get a parallel currency, the ROC. In the UK, since April last year, you will get 2 ROCs for every megawatt hour. In Scotland, however, you will get 5 ROCs for every wave megawatt hour, and you'll get 3 ROCs for every tidal megawatt hour. You can see why the development has been faster in Scotland than it has in England and Wales. It's not just the resource, it's also politics. We could talk about renewable obligation certificates for the next 5 hours. And there might be one economist in the room who would be absolutely fascinated by this, and everybody else would go to sleep, so I will rapidly skip through that and talk about some of the other policy drivers. The Marine Renewable Deployment Fund, a governmental fund to support the early development of pre-commercial technology. £50 million, in which developers can receive capital grants and can receive revenue payments for their electricity. Again, intended to stimulate a developing technology. It's quite difficult to get into. Basically, you've got to show you can do it before you get money. If you want to step up to that, you can access something called the Marine Renewables Proving Fund. They'll love the acronyms in this business. A smaller fund, but this is a sort of stepping stone fund to get things going. Up in Scotland, we have something quite different, the so-called Saltire Prize, announced 2 years ago now. It's a £10 million prize. It's intended to mimic the X Prize, the prize to get a commercial space vehicle. To win this, you must be able to generate 100 gigawatt hours over 2 years into the grid in Scotland. It's a statement of intent. I reckon it would take you about £25 million to win that £10 million prize. So it's not going to pay for your development. It's more a flag. The X Prize stimulated activity. I think they paid about 5 times the value of the prize to get it, and it'll be the same with this, maybe 2 or 3 times the prize. Okay, say a little bit about the developmental process. If you're going to design marine systems, you have to understand the physics, you have to understand the mechanical engineering, the electrical engineering, etc. You cannot separate any of those processes. You have to take into account your whole installation process. You have to design technology that can be installed. You have to design technology that can be connected to the grid. The purpose of organisations like EMEC, the European Marine Energy Centre, is to let you try that for a full-size device and then feed that expertise, that experience back into the process. Now here is the location of EMEC. This is Orkney, off the north coast of Scotland. The wave site is here, just off the small town of Stromness. The tidal site is here, just off the island of Ede. This organisation was established by a raft of public bodies. However, it operates as a non-profit making company. It now receives no governmental funding. It exists purely on the funding it receives by letting out its berths. The wave site was opened in 2003. Originally 4 grid connected berths in 50 metres of water, about 2 kilometres offshore. Here's the power cables running offshore. Here's the substation, beautiful piece of civil engineering. It's visible from virtually nowhere on the island, and that was a condition of the planning. We go out to the tidal site. This stretch of water here is known as the Fall of Warness. This is the island of Ede with a population of about 100. That island there is called Buckle Green Home. That's Little Green Home, uninhabited apart from about 50 feral sheep. And if you think of sheep as soft, fluffy, woolly things, go on that island. Nothing different, believe me. Here's some of the activity ongoing at EMEC. This is the first Polaris under test. There's the open hydro system. This is a turbine being installed by Rolls-Royce, originally Time Generation Limited, now 100% owned by Rolls-Royce. This is activity by Aquamarine in the installation of their Oyster device. This is the most recent work that's ongoing. This is the 2nd generation Polaris, which is being installed right now. And this is a rather strange turbine by a company called Atlantis. It's a push-me-pull-you type turbine, which is also being installed literally right now. So this is the latest round of activity at EMEC. Okay, as we move forward to the close, what are the issues that we need to concern ourselves with? Think about waves, survivability. You are putting technology into the sea, which is designed to absorb energy. The shipping industry designed ships not to absorb energy. The offshore petroleum industry, likewise. This technology has to be sensitive enough to extract energy in small seas, yet must be tough enough to survive the very biggest seas. There's a huge range of forces that they're going to have to live with. Wave power devices produce rapidly fluctuating cyclic supply. That's a challenge to the electrical integration engineers. And of course, this energy is offshore. How would you get the energy where it will be consumed? All of these are technical challenges.